Hello and welcome. Introduction. In this video, I'm going to show you how to program the RARS or RISC 7-segment display. RISC 7-segment display. Now, this is the RISC-V Assembler Runtime Simulator, or RARS, RISC. Now go to the this toolbar here and click on the Tools option, and then choose the Digital Lab Sim option. You will then see this. Now this is the Digital Lab Sim tool. It allows you to interact with the memory map I/O for a hex keypad and 7-segment display. I'm going to focus in this video on the 7-segment display. Now each 7-segment display has a unique address. The right display has an address of 0x, that is indicating is a hex value, FFFF0010, and the left display has an address of hexa FFFF0011. Okay, let's take a closer look at the right 7-segment display. Now, although I'm focusing on the right display, what I said here or discuss here applies to the left 7-segment display. Now, each bit of a byte address of 0FFF0010, each bit here controls a certain segment. For example, bit 0 will control segment A, and bit 1 will control segment B, bit 2 will control segment C, and so on. So if we set, for example, bit 1 to a 1, and then bit 2 to a 1, we will get a binary of 0, 0, 0, 0, 0, 1, 1, 0. And in hex, that would be 0, 6. And with this binary pattern, we will then get a decimal 1 display on the 7-segment, as shown here. Okay, now let's take a look at another example. If we set bit 0 to a 1, bit 1 to a 1, bit 2 to a 1, and bit 3 to a 1, and then bit 6 here to a 1. Now we will get a hex value of 4F hexa. Now this will then give us a decimal 3. The program. So here is the program or code that I'll be using to display 2 hex values. Let's walk through this program. Now, here we see a .eqv. Now, .eqv is an assembler directive that is used to define a constant. Now, EQV stands for equivalence. It tells the assembler to treat this symbol, for example, treat this symbol as equivalent to this constant value. So in this example, left digit is a symbolic name, and it has a constant value of 0x. 0x here is denotes hexa. So it's F, 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 0, 1, 1. That's the value assigned to this symbolic name. Similarly, here we have right digit, which has this hex value, F, 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 0, 0, 1, 0. And these hex value are the addresses for left digit and address for right digit, respectively. Now, .text, this is another assembler directive that tells the assembler the following lines are machine instructions and put them in the code segment area. Okay, next is main. Now, main is just a label that marks the starting address or starting point of the main program. Next, here is the LI instruction. LI A0, comma, hex 06. The 0x here denotes this is a hex value. So let's take a closer look at the LI instruction. So LI here stands for load immediate. A0, that is the register, and 06, as mentioned earlier, is a hex value that we want to store or copy into A0. Next is this JAL instruction. So JAL, show right digit. This is a function which is defined here. Show right digit. So this is the function. And this is another one, show left digit. We'll come to this in a few moments. So JAL, show right digit, that is jump. JAL is an unconditional jump. So when this instruction is executed, it will jump to that function and execute it. And JAL stands for jump and link. So basically, JAL is a function call. Then we have the next two instructions. And if you look at these two instructions and compare it to these two instructions, basically they are almost identical, except that here we have 4F being copied into a register A0, and the jump this time is to this into the function called show left digit, which is this one here. All right, so let's move on. So next is the exit. Exit is just a label similar to main. And here we have another load immediate instruction. This time is load immediate, register A7 with the value, this is a decimal value, 10. Now, 10 is a system call number. So basically, we're loading this system call number into A7. And A7 is designated, a register designated to hold system call numbers. All right, it's specially designated to hold system call numbers. Next is eCall. Now eCall, this is an instruction that actually makes the system call. Basically, you're making a request to the operating system or the simulator. Now, since A7 is 10, eCall will execute, it will tell the operating system to stop running. So A7 works together with eCall. So when you do an eCall, it will look at A7 to look for the system call number. Now, in our case, for this particular example, we have decimal 10, and that basically is a call to exit. And finally, we have this label, END, end, and this marks the end of the main program. Okay, so next are two functions. Okay, here, show left digit and show right digit. Now, the show left digit here, highlighted here, is a label which marks the start of a function named show left digit. So this is a function. Next is the LIT0, comma, left digit. LI is load immediate instruction. Let's take a closer look. All right, so LI, as mentioned earlier, is load immediate. We've covered this in my previous video. T0 is a register, and left digit. All right, this was defined earlier. Remember, right at the beginning of the program, we have a .EQV, left digit 0x, that's hexa, F 0011. So in other words, this value has been assigned to left digit, which is an address. So this instruction here will load T0 with the constant left digit, which is this value as mentioned earlier. So now, when this instruction is completed, T0 will contain this value FFFF0011 hexa, which is the memory map IO address for the left 7-segment display. Right, next comes the SB instruction. All right, SB A0, comma, 0, open bracket, T0, close bracket. So SB stands for store byte, and A0 is the register, and 0 bracket T0, that is the register, T0 is the register with offset. The offset here is 0. So basically, this instruction will store the byte in register A0, whatever is stored in A0, which happens to be the 7-segment pattern. In this case, it will store this 7-segment display value into memory address pointed to by T0 with the offset. Okay, so next is the show right digit function. So show right digit highlighted here is the label. If you notice, this function, this show right digit function, is identical to the show left digit function, except for the show left digit. This here is left digit, and this one here, this label here is the right digit. All right, so let's come back to this. So this is load immediate T0 write digit. So basically this loads the constant write digit, which is this value here. All right, this value F, 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 0, 0, 1, 0, hexa. All right, so this is then copy or loaded into T0, and then this store byte here will store the contents of A0. All right, the contents of A0, that happens to be the 7-segment pattern. All right, and then you store it into not into T0, but into the address port that is contained in T0. That means T0 is the pointer to the address where it should store the 7-segment pattern. And then finally we have this JRRA. Basically, JR is a jump register instruction. RA is a register that contains the return address to the main program. So this instruction here will return the control back to the main function. Code demonstration. Okay, so here we are in the RISC simulator. So I've uploaded the code here. Let me just briefly go through this with you, and then I'll run the code, the software. So here, the first two lines here I assign the addresses of the left digit, this value to the left digit, and assign this value to the label here, right digit. The first one here is the address of the left digit, and this is the right digit. So here I have my main function or the main program, starting this point here, and ends here, and then followed by the definition of the two functions, show left digit and show right digit. All right, so that's the code. So let me just go to run and assemble it. And here, if we look at the messages panel, it says that the operation completed successfully. So now we go to Tools, Digital Lab Sim. All right, so here's the Digital Lab Sim with the 2 7-segment and the keypad. So if you go down to the bottom of the Digital Lab Sim, you have this connect to program. So if I click on that, now it's connected. And if I go to run and then choose go, and we have the result displayed on the 7-segment display. Now you could work out the code for different numbers, and then you try it yourself. Okay, for now, that's the demonstration. Okay, that's it for this video. I hope you have found it useful, and I'll see you in the next video. Bye!